did was a new thermostat. It's programmable. It's connected to the internet so I can look at it remotely. There's an image of my cell phone from a few months ago showing what my house is doing. It will send me an alarm on low temperature. We go to Florida in the winter. The alarm feature is very useful. It's a way to tell me something's wrong with the system. And I can adjust it remotely. The only thing I couldn't do was uncover the air conditioning unit on the outside of the home, but I found somebody that would do that for me. So in probably June, I changed from a heating mode to a cooling mode to get the system ready for our coming home. That ended up not being until July 20th. So we were into a standby mode, setting the temperature up to 80 degrees, but finally getting down, because on the drive home, I moved us back from standby to a scheduled mode. If you don't have one of these in your home or your lakeside place, they're very useful. Big picture, a lot of work improving the insulation of the house. I've always wanted to do that. Back before we moved in 2005, we changed out all the old windows. We added some insulation in the ceiling, but now, this time, I've improved insulation in the ceiling even more, which was done by the folks doing the solar work. And I found a way to add better insulation into the sidewalls of the existing home. And the really big part was adding solar cells to the roof. So I'm now generating power. And the way electricity is not being used very much today, I'm sure you're watching this based on power generation from my solar cells. A lot of this work started by seeing ads on Facebook. That's where I found this company that did the insulation on the sides of my home. Retrofoam, out of a suburb of Detroit, Michigan, but Lakeside is part of the territory they claimed. My house was built in 3 different stages. The front part, the old 4-square design, was done in 1923, so it's approaching 100 years old. It was not insulated in its original form. I had the upper bedroom extensively remodeled before we moved in, and those walls were insulated. I had a company blow cellulose insulation into the sidewall on the side, the south side, and the front side of my home before we moved in. In 2005, or those were the 2005 things. In 1978, we'll see it more later, but a 1-story addition was added to the rear of the home, and that was insulated when it was installed. And in 2003, a little before we purchased, they added a 2-story addition to the rear of the house, which is a wonderful family room with the ceiling 21 feet tall, a 2nd floor bedroom, a nice 2nd floor bathroom, and that was all insulated. But knowing or hearing the stories of the builder who was low budget, and some of the work really looks like it, and who went out of business after this project, I was very concerned with the insulation in the back of the house. These guys use a foam insulation. This is the back of my house. This is part of that rear wall. You can see better in this picture. This is a closed cell foam insulation. Think of foam as a bunch of popcorn kernels, but miniature size, that are glued together with a resin coating to make a solid wall that is a pretty good insulator and has the added benefit of filling up any pockets that exist and sealing the surfaces. The way they do this is remove a strip of insulation. They've already done it on this wall. This guy is starting to remove an upper strip. Here we have a whole strip, or removing a strip of the sidewall panel. This is easiest on vinyl. They can do the same thing in brick by drilling into the corner of the bricks and using smaller nozzles. A wood-sided house they can do. A cement fiber-sided house is probably a lot more difficult. So they remove that, they cut the Tyvek, which is really the waterproof coating for the wall, hold it down, drill 2.5-inch holes between the studs, and this guy sticks a nozzle into the wall. And by the way that nozzle feels, he can tell if he's got the cavity filled. We'll look at that in a minute. After he does this work, this foam is water soluble. It's not like the stuff you buy in a can that's not water soluble and really sticks to everything. This cleans up very easily with a damp rag. Even rainwater will take it off. So it's a very easy cleanup. This foam does not expand. So you can put it behind the drywall. He puts it in that wall, and any insulation, fiberglass insulation that's in the wall is compressed against the drywall, and most of the space then is filled up with this foam. His truck has a foam generating system and a resin generating system in the back, or in this case, the trailer. So everything comes in, is mixed at the site and injected into the wall. This is a practice wall or a demonstration wall. So we have a drywall surface over studs. It's got insulation in it like a normal house construction, but instead of an outside wall, it has a plexiglass surface so you can see what's happening. This is the nozzle. He's stuck down into the wall. As he fills up the wall, the foam is pushed back. You can see how it's already back farther than this next space. And the space is filled with foam, so it looks like this. The other thing they do in this whole process is there's a person that goes inside the house, takes at every electrical connection in the outside walls, takes the cover plate off the little switch area and injects foam from a pressurized can into the four corners of that opening, because that area is the area hardest to insulate well. So they do that insulation with a visual inspection on all the outside walls to make a really well-insulated product. So these five guys were able to go through this entire house doing most of the one side, the back, the north side, and the common wall inside the garage, between the garage and the house, in about 5 hours worth of work, and had everything put back together. And I thought it was surprisingly affordable for a really great insulation system. Now, the next Facebook find was a solar company. Ads on Facebook, people have finally figured out, are a way to reach a lot of people. Power Home Solar is now in 10 states, including Ohio. I'm not sure what their Ohio offices are now. When I used them, it was an office out of Michigan servicing Ohio. They started as a company in North Carolina, started doing alarm systems. That business got killed by cable companies. Too easy to do an alarm with a cable company. So they went and said, solar sounds good. And they quickly figured out that if we're going to do solar, it helps also to do roofing, because most people will say my roof is going to need to be repaired within the next 10 years, so I don't want to do solar now. So they are now a GAF certified roofing company. And they did a good job because I used them for part of my roof. So I called the number. First answer was, well, give me your address and I'll look at what you look like on Google Earth. So this is my house, Vine Avenue. I have a yellow outline of what the house roof is. The south surface of the roof, which is the best for solar, is the new roof in the back and part of the 4-square roof in the front, which is less than 10 years old. I had that redone sometime after we moved in. This roof was 17 years old. But the first person I called said, your house looks too shady to do solar. And I said, but that's a morning image. No wonder it's shady. Nope, it's too shady. So I stopped talking with them until I saw the ad a few weeks later and called again and got the same response. So a few weeks later, I called again, and this time I found somebody that said, oh, you say that's morning sun? Maybe it'll work. Let us put a quote together. They use Google Earth to estimate the size of the roof, which gets pretty accurate. The only thing they can't do is know exactly what the slope of the roof is. But they're close. So they looked at the dimensions and said, well, the other thing we need is your electric bill. Can you do an image of an electric bill and send it to us? Because it has on it your electric consumption by month. And eventually, after doing all that, they came back and said, we think 14 solar panels would be good. And the first little quote was 3 panels on the north or west side, because they really didn't know how big this tree was, and 3 panels on this side, and 8 panels on the sunnier part of this roof. So that was my first image of what this all might look like, and what the price might be, and what the payback might be. And that's what I submitted to HP&DRB to get approval. This is an external modification to my home. I need to get Lakeside approval. Now, by the time I submitted to Lakeside, the drawings I got from the company said 3 panels in this spot and 11 panels back here. Because I guess by then they figured out this tree is going to be a problem with the west-facing panels. So that's what I went for approval, which was really pretty easy to get. And I should say that my work with the solar company was a new roof for this part of the back roof. Like I said, 17 years old. Solar panels have a guarantee of 25 years. I didn't want to be later, probably earlier than 13 years from now, taking off the roof or the panels so I could re-roof it. So I said, give me a quote that includes this roof, which they did. And that's what we approved. The back re-roofing was easy. It was a shingle. It was much like what I had on there. There was a bit of discussion about the solar panels. And at that time, I was still talking 3 further forward. But everybody said, that's the way the future's going. We need to get on board. So I got approval in early July. The guys that do the roofing for that company really wanted to get started as early as possible because they had time available. And I had to keep telling them, in Lakeside, you have to wait till the season is over to do the roof. But just about right after the roof, they showed up and did a nice job of re-roofing this and this little bend area of the old roof and finished up in one day with a nice new roof. About a week later, these 6 folks showed up. 3 of them, I think it was, were working on the roof part. The other 3 were doing things like getting all the other electrical work ready and blowing more insulation into my attic. They're coming out of Michigan, another suburb of Detroit. So they showed up around 10 o'clock. And about 5 hours later, they were finished. They worked as an incredible team doing the work. So this is what I had in my application. The first thing they did was, well, let me show you. This is my 11 panels back here, 3 up here, 2 little devices that let them go take the wiring inside the attic. Because to get to the other side of the house, they go through the attic. Drop down into the inverter, through a disconnect switch, and over to the panel that has my meter on it. When they showed up, the guys doing the roof work did a couple quick measurements and said, we can put all 14 panels up on this roof. They fit nicely. And I said, go ahead, we'll get rid of putting panels up in this part of the house. So that's the first change. Notice I have almost a perfect south face. And a lot of Lakeside is arranged so roofs have a nice south face. That's the perfect place to put your solar panels. Just don't put them in the shade. First thing they did was find where the roof trusses are. This is the base plate that attached, nailed into a roof truss to get a nice firm anchor. On that was a little pillar, all put together with good stainless material. The support for the solar panels is going to be attached to this little pillar. So this is arranged so it won't leak. The attachment is under a shingle. Then they put the rails up on the top that the panels are going to sit on. And that was a pretty quick installation. So I've got this arrangement of rails up on my roof for panels to sit. My panels are a US fabrication. Silfab is a company in Seattle, Washington, that also has a manufacturing plant in the Toronto area. At the time I had my work done, this was their standard panel. 60 cells, a little over 5 feet tall, a little over 3 feet wide, 1.5 inches thick. It only weighs 42 pounds. Has a 25-year guarantee. What does that mean? The guarantee is, panels slowly lose their generating capability over time as electrons are kicked out. Photons hit the cells and kick out electrons. In 25 years, this panel will produce 85% of its rated capacity as a new panel. So it drops a bit on output over 25 years. Its actual lifetime is probably longer. It's a guarantee that's transferable because I sincerely doubt I'm going to live another 25 years. Panels change with time. This company makes panels of different sizes. There's a 60 cell panel, there's a 72 cell panel. They keep improving the crystalline material they make the panels from, and that it keeps increasing the efficiency, not by much. These panels are capable of converting about 18% of the sunlight they receive to electricity. New panels may be 19%. If you have enough space on the roof, this doesn't matter. What you're looking for is a reliable panel and the lowest installed cost per kilowatt. So using a panel design that's a couple years old is not a disadvantage. So the panels show up in the back of the truck. That was a stack. They had one extra panel. If you count the little white marks, there are 15 of them. So I assume they provided an extra panel just in case something happened. The rest of the stuff in the truck is all the other supplies they need to put this together. And a guy climbs up the ladder, one panel at a time. So that was 14 climbs. And they lay them out on the roof and eventually fastens them down. You can see little bumps on each side of a panel, there, 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 and there, which is the clamp that holds it to the rail going back and forth. The wiring is collected together. I don't know exactly what that arrangement is, but up above the panels on the roof, they have a metal housing to shield the hole through the roof that drops the wire into the attic. So now panels come two different colors, it turns out, and that's based on who built the panel. Mine are really all black. From a distance, you don't see the lighter colored lines. Some panels have white edges and white dividers between the cells. Just depends on who the manufacturer is. They both look fine. I kind of like the all black because it kind of goes with the color of my roof. Wiring went through the attic. We drop down out of the soffit area into a conduit. So the wire ran across my attic, and the house is all a vaulted ceiling until I get into this area. So this was about the first time he could come out of the attic. Otherwise, he would have dropped out of the attic right here, but he had no access to get to that point. And then the wire, now we're talking a DC current, I think it's a 40-volt DC, is in metal conduit until it drops down to the inverter. So on the north side of the house, that's what the inverter looks like. There's a DC disconnect switch into the inverter, which changes it to AC. It's a really simple system. This inverter is made by Solar Edge. My subsequent reading said that is one of the premier inverter manufacturers. It's also a 25-year guarantee. Notice the little antenna. It's because this broadcasts a signal that gets picked up by a receiver inside my house that's connected to the internet, so I can view the production of this electricity on my telephone anytime I want to. And a little later, I'll show you the type of image I get to view on my telephone. Then I come out of this now as AC current or electricity to the disconnect switch for the entire system. And notice that they have labels about everywhere to say there's a solar power system connected to this, folks. You have to turn off both the Ohio Edison electricity and the solar electricity if you want to work on the system. So out of a conduit at the bottom and off to connect to the box. I have a little bit of a strange electrical system because my house was built in a couple different phases. So I have two electrical panels, circuit breaker panels. One's inside the house. I think this one goes inside the house and to a breaker panel that's in this room, but it's not close to this part of the room. The other one goes into the wall, goes up through the garage into a room that's become a utility room on the second floor. Each one of these big panels has a disconnect switch, so I can isolate the panel, electrical panel, on the other side of the system. That's a bit unusual. Normally you don't have that. You just go from here to your circuit breaker panel. Inside there, I have wiring that does roughly this. I come from my meter through a disconnect switch into one panel, from the meter to the disconnect switch to the other panel, and from my solar panel back into the common line that connects between the meter and my house. So solar electricity that I generate first goes into my house to feed whatever electrical units are running. If I generate more here than I consume in my house, the excess goes back through the meter and onto the Ohio Edison grid. As the salesman said, you're using Ohio Edison like your battery. And I said, well, not quite, but Ohio Edison does eliminate the need for me to have a battery system. So I am always dependent on Ohio Edison working. If I lose the power from Ohio Edison, the rest of the system will shut down. If I had a battery, I could use the rest of the system until the battery would shut itself off. But that's the electrical. So that's what these rest of these guys were doing. And then one of them did blow some more insulation into my attic, because the solar people know that the first thing to do is reduce the major electrical uses in the house. I want to get that done before I start looking at solar. So they gave me, were included in their price, more insulation for my attic, and they included 16 LED 60-watt light bulbs, which I still mostly have in the box because I had already converted my old bulbs to compact fluorescents, and then as they were going, changed them to LED bulbs. And that alone is a very dramatic decrease in the amount of electricity a house uses. Final thing. So these guys finished this whole installation in about 5 hours. Next, I had to get my the whole system inspected, which was just a matter of getting the inspector for Danbury or for Ottawa County scheduled to come out and spend about a half hour looking at it. Never opened up a thing. He just kept looking at it and said, yep, they did a good job. Then I had to sign a contract, final paperwork with Ohio Edison, because I am now a power plant. If you could read my t-shirt completely, it would say, powered by solar panels. So I needed the new meter because this one measures both electricity that I consume and electricity I send back into the Ohio Edison grid that I get credit for. Now, I'll show you what happened in a bit with that. So here's what the house looks like today. There are my panels sitting on the roof in the back. They're very happy up there. You barely see them. You got to stand in the right location. But if you come by, I'll give you a personal tour of the whole thing. It's 223 Vine Avenue. So what did it do for me? One of the government offices, Department of Energy, has a website where you can predict how much solar power you will make if you put up a system. There are a few guesses that have to go into it, like efficiencies of the inverter and power loss in the wires. But I put up the data for my system. My 14 300-watt panels make 4.2 kilowatts. So I ran their model with a 4.2 kilowatt system. With my geometry, I'm almost south facing. I could move that direction about 25 degrees either side of south with only about a 5% change in the output of the system. So it's not real sensitive to direction, but it does matter. Roof slope, same way, it matters a little. This is what that prediction looks like. And note that it's more than a 2-to-1 change from winter to summer. One reason why you have to have more than just solar power in the grid It doesn't make power at night. It doesn't make as much power in winter as it does in summer. And I need something on the grid that I can control this whole system. I got curious, what would Florida look like? We have a place in Bradenton, much further south. So I ran the same model for Bradenton. That's where I really confirmed to me that this model also includes a prediction of cloudiness. Because notice how Florida drops production during peak part of hurricane season, July, August, September. But winter's a lot higher production than Lakeside. The model, you put in your location by zip code on both places, Florida and Lakeside. It says it was using data on climate and solar impact that was measured within about 1 mile of where my place was. So it should have been pretty accurate. Now you look at Lakeside and look at Florida. There's a summer to winter variation. It changes. Some of it's the cloud. But why else is it changing? Well, the Earth is actually about 8 million miles closer to the sun in winter than it is in summer. But Earth has an atmosphere around it. And Earth is tilted about 23 and a fraction degrees off its axis. So in summer, the light shines through the atmosphere for a lower distance than it does in the winter. And the distance the light shines through the atmosphere determines how much of the solar energy is lost. This is why sun feels different in summer than in winter, why the sun feels a lot different in Florida in the winter than in Ohio in the winter. It's the attenuation of the atmosphere. Now, how did I do? I already said I know I'm a little cloudier or a little more shaded in the morning than the model would have considered. I also think I might be a little cloudier because we quite often have morning clouds over Sandusky Bay. I'm producing month by month 100 to 150 kilowatts less than what the model said each month. So I think it's a combination of maybe our weather compared to the average that's in the model. I'm losing maybe 100 kilowatts a month due to the morning shade. I have touched base with Dan the tree man, and one of these days he's going to show up and trim my neighbor's trees so my solar panels are not quite as impacted in the morning. This was the best day that I've generated so far. This is my morning shade effect because I expect that the morning sun should come up and kind of do that to me. Something up there with a few hours in the middle of the day that are pretty much constant. This day I generated almost 24 kilowatts of electricity. That was back in May. I just haven't come quite close to that in June and July. Morning shade, as I said, probably a little morning cloud. Clouds have a huge impact on solar. This was a bad day. I generated about 1 2/3 kilowatts. Look at the difference in the scale. This goes up to 4. My system rated at the solar panels is 4.2. I got about 3.7 out of the inverter this day. Even a little bit of haze is noticeable. Well, this was a bad day back in April. Pretty rainy most of the day, as I recall. I wasn't here, I was still in Florida, but my system tells me what the weather is. This only goes up to less than 1/10 of what this scale is. But here was an ugly day from December. This had to be a lot of snow. I generated 100 watts or kilowatt hours, not much electricity. Very low generation. I may have been snow covered that day from the previous day. It's a black surface. Snow will melt off it if the sun's there. You don't have to worry about it. So how is it done on saving me electricity? Because the sales pitch to me was, the system should generate about 55% of your electric usage. And if it generates that, the system cost can be rationalized with less than a 10-year payback. And the payback very much depends on what's going to happen to Ohio Edison's electricity cost in the next 25 years. Well, this is off the Ohio Edison website. Where do they think I use electricity based on their simple models? Well, they think about 16% of that goes for cooling. Really heating and cooling, because the furnace fan runs when I heat also. They think about 27%, wow, goes to my television, my cell phones, my computer. Maybe a little high. 14% goes to lighting. Okay. The biggest part is the appliances, because my range, my refrigerator, my dishwasher, and my dryer are all electric. I've got a strange mix in the house. I have a gas furnace, a gas water heater, and everything that was before the final edition was based on electric. Well, that's an estimate. If I lived here year round, I plan to spend about mid-April to mid-November in Lakeside, but I like to avoid winter. So my goal is to head to Florida around mid-November, which should get me out just before the first snow, and not come back till hopefully after the last snow. So I have no appliances, very little entertainment other than my modem, and very little lighting except a couple that I programmed to come on. So an awful lot of this is really much less usage than the chart shows. But many of you will have usage something like this. So this is my actual electric consumption as far back as I could go with the electric bills that I still have. My solar system, or my electric bills, are roughly incremented at the middle of the month. So this is last half of December, first half of January, etc. When I'm gone, my house is turned down to 55 degrees. And that doesn't change until I get back home sometime in April. Summer, my electric bill can be all over the place because air conditioning, I think, drives the biggest part of it. So I'm questioning some of Ohio Edison's predictions. And then I go back to being absent and back to more predictable. That's 2 years of electric use. What did my system do? Well, now my electric bill has this unique little portion on it, which you may not have on yours. You can see kilowatts used, kilowatts returned to Ohio Edison. My January bill, I used 458, and my system's going as much as it can all day. So there were times when my house was not taking in electricity and I could convert it or transferred a whole 41 kilowatts back to First Energy. Not real dramatic. Well, here's my April, May. I used only 102 kilowatts and sent 333 kilowatts back. I, on net, transferred 231 kilowatts back to First Energy. The rules in Ohio right now are, I get the same money back per kilowatt as First Energy charges for what I use. To me, that's very unfair to the electric system because most of their expenses exist whether or not I use power. But that's the way the system's set up. That's the way my contract is with First Energy. So this is my net consumption in the solid lines. A pretty decent reduction on the winter months, not half, but approaching. And then I have 3 months in a row of negative electric bills. It's only about $25 or $30, but it's credit that will start to be applied back on the electric bills into the future. So I'm judging roughly the system's doing what it was advertised to do. I've generated a whole 3 megawatt hours of electricity as of the end of July. Remember, Davis-Besse is rated at almost 900 megawatt hours. I'm not putting much back into First Energy. I have reduced my CO2 emissions. It's pretty easy to get an equivalency, assuming an average coal-fired power plant, to go from megawatts to pounds of CO2 reduced. That's a straightforward number. Something that's a little more magic, and I'm trying to get an answer on, is they also think that reduction is the equivalent of planting 35 new trees. That thrills me because Lakeside, you with your donations to Lakeside, paid for planting 31 new trees in Lakeside last fall. The system thinks my solar panels planted the equivalent of 35 trees. Great. So what did it really cost? Well, just the solar part was somewhere around $22,000. Last year, there was a 30% tax credit for investment in solar. Since I had the roof done as part of the solar installation, the 30% also applied to the cost of the roof. So my cost after credit was a little over $15,000. Now well, I should say, this is financed through Power Home via a loan from a company called Loan Pal in California. It's a 20-year loan. It's 0 down, 6% interest, and it has the understanding that within the first year and a half, I'm going to pay at least the 30% tax credit. I chose to pay more, which means only that the loan will be paid off sooner. It amounts to $135 a month. No, I haven't tried to check that against my cost of electricity. Summary, I'm really satisfied with the system. I spent my career designing boilers, mostly coal-fired, for utility power plants. I spent my career helping people put more CO2 into the environment. I finally did something on my own that made a small reduction. Last year, the tax credit was 30%. This year, the tax credit's 26%. Next year, in 2021, the tax credit is 22%. Now, I've noticed in the ads, the solar companies are dropping their price to try to offset the tax credit, which only confirmed my suspicions. They make a lot of money on these. They also employ a bunch of people. The tax credit is scheduled to go to 0 in 2022. Whether it gets renewed or not depends on what Congress looks like next year. The election in November, to me, is critical. If you're interested, the guys I used, Power Home Solar, I think they're very reputable. I was pleased with their workmanship. The guys really knew what they do. The inverter they chose is one of the premier inverters based on reading I've subsequently done. You can give them a call, 1-800-POWER-90. If they have an office closer to us now, I'm sure they'll give you a reference. If you decide to do something, mention my name because they promised a rebate if I gave them references. I'd appreciate that. I'm going to try one more idea. I purchased it while we were in Florida. Not sure when I'm going to get it installed. It's called a mist box. What it is a control panel that sits on my air conditioner. It just clips to the side of the air conditioner, receives water from a hose going to a faucet. So it's something I'll turn on in spring, turn off in the fall, drain the pipes, and I'm in good shape. Has a little air turbine generator on the top, so it makes, when the air conditioner is running, it uses the airflow out of the air conditioner to create a low voltage electric current that moves a valve to admit water to a high-tech water filter, and then the hose. And around the four sides of the air conditioner is a little nozzle block with a fine hole in it, so it will turn out a puffing mist, which drops the ambient air temperature close to dew point temperature. So it's going to drop the ambient air temperature 10 or more degrees, depending on relative humidity, which will make the air conditioner run more efficiently and reduce the power usage. I'll let you know next year whether I thought it was worth it. This another ad I saw on Facebook. It's only $200. I said, well, the technology sounds good. The key is going to be a really good water filter so I don't plug up the little nozzles. So we'll see. Now, a dream I have, and our home in the commercial division has done a preliminary quote to Lakeside. We have a beautiful flat roof on the administration building. It's big, it has some obstructions, but it has a huge amount of area, and it's not shaded. To me, this would be an ideal place for a solar field. They'd be on low mounting racks, just sitting on the roof, not attached to the roof, because here they could just sit. Angled at a slight, maybe 5 degrees, just so water drains. Generating more than half the power needed by the administration building. And this is an ideal building. A lot of the power consumption is daytime only. So we've got a quote. It's a bunch of money. As you know, 2 things. First of all, Lakeside doesn't have a bunch of money. Even in a good year, we don't have a bunch of money. Number 2, Lakeside is a not-for-profit, which means we are exempt from income tax, so we can't use the tax credit. Ideally, this could be done by an outside investment firm that would buy the panels and install them and receive from Lakeside probably a fixed monthly fee, just like a mortgage payment. It could be done by an individual in Lakeside. And we have such individuals for a 6-figure investment on solar panels would be closer to pocket change for me. And that person might find that income tax break rather beneficial and might want to do it at a reasonable interest rate to Lakeside. So there's still the potential of having this someday come to a real vision in Lakeside. We'll see. So I think that's the end of my talk. I encourage you to become more green. And we'll get out of screen sharing. I hope. Oh, stop share. And see if we have any questions that have shown up from the audience. And I am not seeing questions in either the Q&A part or the chat part. So I think we have done a bit more than an hour. If you have any questions, you know where I live, and I would invite you to come by sometime, talk to me, just stay 6 feet away from me and wear a mask because we care about our health. So, thanks for being here.